Hello students, in this video we shall learn about the allied angles. Allied angles are also called as relative angles. So now what are allied angles? Okay, if theta is any given angle, preferably acute angle, then the angles of the form n pi by 2 plus or minus theta, where n is any integer, are called as allied angles. So what is the meaning of this? Suppose I consider the angle like 120 degree, 135 degree, 150 degree, then 300 degree, etc. Then I can write this 90 degree as 90 degree plus 30 degree. So at that time what I can say, 30 degree is the acute angle, 120 degree is an allied angle to 30. Okay, 135 means how I can write 90 degree plus 45 degree. Here 135 degree is allied to an acute angle 45 degree. 150 is there, 90 degree plus 60 degree. 150 degree is allied to 60 degree. 300 degree, here we can write it as either 270 plus 30 degree. 270 how I can write? 3 times of 90 degree plus 30 degree. That 90 degree is nothing but pi by 2. So odd or even multiple of 90 degree, an integral multiple of 90 degree plus the acute angle. If the angle is expressible in this form, then I can say that this 300 angle is allied to 30 degree like this. Here got what are allied angles? Suppose I consider one more angle, say 210. I can write it as 2 times of 90 degree. It is 180 plus 30 degree. So 210 is allied to 30 degree. Similarly, any angle you can take. Suppose I take the angle as 225 degree. How I can write? 2 times of 90 degree plus 45 degree. So here 225 degree and 45 degree are allied to each other. So this is what the meaning of allied angles. Since in a quadrant system we have 4 quadrants. Okay, 4 quadrants. Here, you know, is the first quadrant, both x-axis and y-axis are positive. In the second quadrant, x-axis is negative, but y-axis is positive. In the third quadrant, both x-axis and y-axis are negative. And in the fourth quadrant, x-axis is positive, but y-axis is negative. Okay. If the angle is theta here, 90 plus theta will be lying here. So, in the first quadrant, the angles between 0 to 90 degree are lying. In the second quadrant, the angles between 90 degree to 180 degree are lying. Suppose I have an angle theta here, 90 plus theta or 180 minus the complement of that angle will be lying in the second quadrant. Okay, for example, ಇಲ್ಲಿ suppose ನಾನು 120 ಡಿಗ್ರಿ ಅಂದೆ ಅಂದ್ರೆ ಅದನ್ನ ಹೆಂಗ್ ಬರಿಬಹುದು 90 ಪ್ಲಸ್ 30 ಅಂತ ಬರಿಬಹುದು, ಇಲ್ಲ 180 ಡಿಗ್ರಿ ಮೈನಸ್ 60 ಅಂತ ಬರಿಬಹುದು. 180 ಮೈನಸ್ 60 ಅಂದ್ರೆ ಇಲ್ಲಿ ಬಂದು ಹಿಂಗೆ ಅಪೋಸಿಟ್ ಹೋದಂಗೆ ಆಗ್ತೈತಿ. 90 ಅಂತಂದ್ರೆ 90 ಪ್ಲಸ್ 30 ಆ ಒಂದು ಲೈನ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿರ್ತೈತಿ. 90 ಪ್ಲಸ್ 30 ಇಲ್ಲ ಅಂದ್ರೆ 180 ಮೈನಸ್ 60 ದಟ್ ವಿಲ್ ಬಿ 120. ಇವೆರಡು ಕೂಡಿಸಿದ್ರೆ ನನಗೆ 180 ಡಿಗ್ರಿ ಆಂಗಲ್ ಸಿಗಬೇಕು. Similarly, in third quadrant, it is more than 180, less than 270, 180 degree to 270 degree. And in fourth quadrant, it is 270 degree kinta jasti 360 degree, one complete rotation. ಇಲ್ಲ ಅಂದ್ರೆ ಆಂಗಲ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಮೆಜರ್ ಮಾಡಿದಾಗ ಪಾಸಿಟಿವ್ ಇರ್ತೈತಿ, ಕ್ಲಾಕ್ ವೈಸ್ ಮಾಡಿದಾಗ ನೆಗೆಟಿವ್ ಇರ್ತೈತಿ ಅಂತ ಹೇಳಿದಾಗ ಇದು ನೀವು ಆಂಗಲ್ ಅನ್ನ -0 to -90 ಅಂತ ತಗೋಬಹುದು, ಅಥವಾ 0 to -90 ಅಂತ ತಗೋಬಹುದು. 0 to -90 ಎಲ್ಲಾನು they are lying in the fourth quadrant. Okay, so this is what the allied angles are. Now I will try to express. Now we shall express all the angles allied to this triangle theta in different quadrant. First, to express trigonometric functions of minus theta in terms of those of theta. So for this we will consider a circle. Okay, trigonometric ratio of minus theta with respect to theta means if the angle is measured in the clockwise direction, it will be positive. Let it be theta. Then this is the radius of that circle and it becomes the hypotenuse. For this theta, if I draw a perpendicular, this line will be the opposite side and this up to this, it is the adjacent side. Okay. Now, suppose the same measurement theta, ಇಲ್ಲಿ 30 ಇತ್ತು ಅಂದ್ರೆ ಸೇಮ್ 30ನ ಅದು ಫೋರ್ತ್ ಕ್ವಾಡ್ರೆಂಟ್ ನ ತಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ ವಿಲ್ ಮೆಜರ್ ಇಟ್ ಇನ್ ದ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್. If I measure it in the clockwise direction, then the angle will be measured as negative, minus theta. Then for this minus theta, let the side opposite to it, I will call it as y dash. This is y, this is y dash. And the side opposite adjacent to this, I will call it as x. For this x, it is x. For minus theta, it will be x dash. And this is the radius of circle. This is the radius of circle means it's also equal to r. I can call this as O, A. I can call this point as B, and this is C. Now, to express the trigonometric functions of minus theta in terms of theta is there. Okay. So, what is the construction? Consider a circle with O as its center. Let angle BOA is equal to theta. It is positive. Okay. Then the side adjacent to this, I will call this point as B. This is B actually. Okay. This is B. Adjacent to this OB, it is X. Then the side opposite to it, I will call it as AB. It is Y. And OA is the hypotenuse. Okay. Now draw. Okay. This is same in measurement, but opposite direction means I took it as minus theta. Draw minus theta in fourth quadrant, minus theta. Therefore, opposite side for minus theta, opposite side is y dash. Adjacent side for this, it is x dash. But here both are x is equal to x dash is there. And then hypotenuse. What is the hypotenuse here? OC. OC is equal to R. It is positive hypotenuse. Now, suppose I want to write the ratios for all the angles. Sine of minus theta. This is my reference angle, minus theta. What is the opposite for this one? Opposite side for this one? It is y dash. Y dash upon R. Now, you look at y dash length. Y dash is as same as y. Okay. AB is equal to BC in magnitude. But as per direction is concerned, it is negative y-axis. So, y dash is minus y. So, I write it as minus y by r. Minus. Y by r means what? It is the ratio for sine theta. Sine theta is the ratio of y by r. So, I can write sine of minus theta is minus sine theta. Okay. So, sine of minus theta is minus sine theta. Similarly, for cos of minus theta, if this is my reference angle, the side adjacent to this is OB upon hypotenuse is OC. OB, I have chosen it as x. The same x is for this side also means it is x by r. You know, for angle theta, what is the ratio for cos theta? Adjacent side to hypotenuse. So, this is cos theta. Thus, cos of minus theta will not be minus cos theta. It is cos of minus theta is cos theta. Then, tan of minus theta. Tan of minus theta. Opposite side divided by adjacent side. Opposite side for this is BC. Adjacent side for this is OB. What is our BC? Y dash. Then, what is our OB? It is x or x dash. Both are x dash is equal to x here. So, now, what is y dash in terms of y? This y dash is same as in length to y, but in negative sign means I can write minus y by x. Minus y by x. It is the ratio for tan theta. If this is theta, opposite side divided by adjacent side. Tan theta is the ratio of opposite side to adjacent side. Thus, tan of minus theta is minus tan theta. So, thus, what we have proved? Sine of negative angle minus theta. Sine of minus 45 degree if I say, you will write as minus sine 45. Minus sine theta. But cos of minus theta will be plus cos theta only, because I took the adjacent side and that adjacent side is positive in first and fourth quadrant. This is positive only. Then tan of minus theta, it is minus tan theta. Similarly, you can write for the remaining ratios. They are the reciprocals of this. So cosec of minus theta is minus cosec theta. Sec of minus theta is just sec theta, as good as this one. Then cot of minus theta is minus cot theta. This is how we express the ratios of minus theta in terms of theta. Okay? I hope you understood. Now, second one. I write to express all the trigonometric ratios of 90 degree minus theta in terms of theta. So for this, I will consider here also a circle with 4 quadrants. 90 degree minus theta I want, and I want to express it in terms of theta. First, basically I will consider one acute angle. It is theta. It is measured in anti-clockwise direction, so it is positive. O, A, B. I can see. This OB is adjacent to this theta, so it is X. This AB is opposite to this theta, it is Y. But what I want here, I want 90 degree minus theta. Now you look at this. This angle is 90 degree, but this is theta. So what this angle would be? It is 90 degree minus theta. So what I will do is, if this angle is 90 degree minus theta, I will choose L angle with this angle as 90 degree minus theta. So for this 90 degree minus theta, what will be our opposite side? This will be our opposite side. I will call it as y dash. And the side on which this lies, it is x dash. Okay. So I will write, consider a circle with O as its center. Let angle BOA is equal to theta. Then for this angle AB, I will call it as Y, adjacent side, or you can say it as opposite side. AB is Y, adjacent side OB is equal to X. Now I want 90 degree minus theta. This much is 90 degree minus theta. Same angle if I take here, then I will get, this is our 90 minus theta. I will call this point as a C. Let angle, I will call this point as D. Angle OCD is equal to 90 degree minus theta. Let angle OCD, this is equal to 90 degree minus theta. What is the opposite for this one? OD. It is, I will call this side as the side opposite to it. It is, OD is Y dash. And the side adjacent to it, CD, is equal to X dash. Since these two angles are congruent, I can say this AB length is equal to this OD. AB is equal to OD. And the side opposite to this, the side adjacent to this, CD is equal to OB. Okay. Now, I write for sine theta, what you will write? Sine theta is the ratio of opposite side to hypotenuse. Cos theta is the ratio of adjacent side to hypotenuse. Tan theta is the ratio of opposite side to adjacent side. But now I am going to write ratios for 90 degree minus theta. So sine of 90 degree minus theta. For this 90 degree minus theta, our opposite side is y dash. Y dash upon the hypotenuse, that is OC, it is R. Our y dash is what? this line, opposite line for 90 minus theta will be the adjacent side for theta. So y dash becomes equal to x by r. You know, x by r is the ratio for cos theta. So thus, sine of 90 degree minus theta will be cos theta. Now, cos of 90 degree minus theta. 90 degree minus theta. The side adjacent to this one is, I will call it as x dash upon r. You know, the adjacent side for 90 minus theta will be equal in length to the opposite side for theta. It will be y by r. You know, y by r is the ratio for sine theta. So thus, cos of 90 degree minus theta is sine theta. Both are lying in the first quadrant, means all y dash, x dash, r, they are all positive. Thus, cos of 90 minus theta is sine theta. Then, tan of 90 degree minus theta. Tan of 90 degree minus theta, opposite side to adjacent side. But you know, y dash is x and x dash is y. You know, x by y, adjacent side divided by opposite side, means that is the ratio for cot theta. Thus, we have proved sine of 90 degree minus theta is cos theta. Cos of 90 degree minus theta is sine theta. Tan of 90 degree minus theta is cot theta. This sine changes to cos changes to sine. 90 minus theta, 90 minus theta. Similarly, for the reciprocals, cosec of 90 degree minus theta. Sine and cos are co-ratios. Tan and cot are co-ratios. Like that, cosec and sec will be co-ratios. So, cosec of 90 minus theta, I write it as sec theta. Then, sec of 90 degree minus theta is cosec theta. And cot of 90 degree minus theta is tan theta. So, this is how we express all the trigonometric ratios for 90 minus theta in terms of theta. Okay. I hope you have understood. In the next video, we shall see how to express all the trigonometric ratios of 90 plus theta